everyone, in this video we are going to discuss that in recent works machine learning community has shown a growing interest in extreme low bit quantization techniques like the bitnet and the 1.5 bit. So these methods aim to revolutionize compute efficiency by enabling matrix multiplication with quantized weight without actual multiplication. So the existing approaches mainly focus on training models from scratch, which can be computationally expensive and less accessible. So that is the quantizing pre-trained models directly with extreme settings, including binary weight, using their adaptation core HQQ. Aim to revolutionize compute efficiency by enabling matrix multiplication with quantized weight without actual multiplication. So the existing approaches mainly focus on training models from scratch, which can be computationally expensive and less accessible. So that is the quantizing pre-trained models directly with extreme settings, including binary weight, using their adaptation core HQQ+. So the HQQ+ is the adaptation of HQQ, which utilizes a low rank adapter to enhance its performance. So by fine-tuning just a fraction of the weight on top of an HQQ quantized model, so they observed a significant quality improvement even at 1 bit, so passing the smaller pre-full precision model in output quality. So the HQQ stands for half quadratic quantization, which is a fast and accurate model quantizer that keeps the need for calibration data. It's super simple to implement, just a simple lines of code for the optimizer. So it can crunch through quantizing the llama to 70 billion in only 4 minutes. So the method leverages efficient matrix multiplication for low bit quantization, rethinking the dequantization step to directly exploit extreme low bit metric multiplication. So by separating the metric operations and employing low rank abductors, it enhances the quantization results. So when benchmarking against full and other quantization methods, the experiments demonstrate remarkable improvement in output quality for both 1 bit and 2 bit models. So notably, the HQQ 1 bit model achieves more comparable performance to the 2 bit model, which indicates the efficiency of the proposed approach. So these findings are just a promising path for making large machine learning models more accessible by producing them and compute requirement through extreme low bit quantization, which is a great news. So we are going to dive into a demo. So this is a blog from the Mobis Labs, right? You can find much detail in here. So this is going to be the introduction, the efficient math for low bit quantization. So we can go through this blog to find out more information on how the dataset that was used. And we have 1 bit, 2 bit chat models, 1 bit model, 2 bit model. Okay, so we go to the Hugging Face, where we have the model from the Mobis Labs. So we have the Llama 2 7B. So we have other, that is a 1 bit model. They have other models. When you click over here, you can see they have the Mixtral 8 7B. So that is 3 bits. We have 2 bits, 4 bits models. So we can check that out, can try different type of models. So I'm going to use the 1 bit model for Llama 2 7B. So let's get into the Colab, and we first go to runtime and we choose T4 GPU. I'm going to save and I'm going to start. So we need to install the HQQ and we load the 1 bits and full precision model. So we are using T4 instance and we are importing the HQQ model, we are importing the auto tokenizer, and we are importing the auto model for Local LLM. So the next thing is we are going to load the quantized model. We are loading this model from Hugging Face, right? So you can go over here and select any model you want, right? Just go here and select any model, just copy this name and you paste it here. So you can use the Mistral 7B, the Mistral 8 7B instruct, right? So I'm using the 1 bit and I'm going to specify the data type for the model to be loaded. So I'm using the float 16 and reload the quantized model using the HQQ model for causal LM. So I'm passing the quantized model ID and I'm using the adapter LoRa, and I will enable cache for faster inference. So I'm going to assign that to true. going to set the model to evaluation mode. So here you have the option if you want to connect that to the Hugging Face. So you may need your access token and it's optional, so I will just let it be. So we have the 1-bit model loaded, as you can see, right? So the next thing we have to do is reload the tokenizer from the quantized model. So we are using the auto tokenizer from the pre-trained. We pass the quantized model ID, so we are loading the tokenizers. Now we are going to set up the inference by configuring the tokenizer, the model. So we set to add the beginning of sequence and end of the sequence. All right, so we are going to set that to false, and we check if the tokenizer has a pad token. So we place it if condition here. If there is no pad token, we are going to give a special token, call it pad, and we will define a function for streaming the inference for the chat interaction. So we import the torch transformers and we create a thread. So from threading we import thread and we pass a function called chat processor. So we are going to pass the chat, we are going to pass the current model, the current tokenizer, and then max new token to be 80. We are going to pass the sample to be true and device is CUDA. All right, so this is disable using the default system prompt for the tokenizer. Okay, so we create a streamer and we use the text iterator streamer to tokenize and stream the input text. All right, so we pass the current tokenizer the time out to return and the skip prompt to be true and skip special token. So all these are redefined parameters that we are going to pass. So we generate the model input by using the current tokenizer, we pass the chat and we pass the streamer. So these are parameters that we are going to pass. The top P 0.8, the top K 40, and the temperature is 0.7. Okay, so we are going to start a new thread for the model generation. So we are assigning that to T and we pass this. The target is going to be target the current models and we are going to start it. We start the thread for the model generation. We want to print the input, we want to print the conversation from the user and assistants and pass the chat, and we collect and print the generated text. So we are going to iterate through the streamer and we extract the text and we are going to put that to the output, and we are going to print the text, and we want to empty the CUDA memory to release the memory resources here and want to return the output. Okay, now we list the questions for the quiz. We are creating some simple questions that we want to pass into the 1-bit model to test it out. So these are sample questions. It's going to pick up random questions. So what happens to you if you eat watermelon seeds? All right, so if you had 3 apples and you ate 2 yesterday, how many apples do you have now? All right. So the assistant is saying you started with 3 apples, you ate 2 of them. So you would have 3 minus 2 is equal to 1 apple left. So the answer is 1, which is not really bad for a 1-bit model. All right. So for 1-bit model and giving such a response is great. I can't wait to see how the future will be for 1-bit LLM, 2-bit LLM, even 3 4-bit LLM. Alright, so I hope you all learned something in this video. Thank you for watching. See you all in the next video.